Okay, here we're going to compute and compare confidence intervals for population proportion, and we're going to answer some concept questions about them also. So the formula is over here. I already went ahead and wrote the numbers from the problem here. You can see that. I'm going to go ahead and type that into our ALEKS calculator. We're going to go 0.37. Let's start off with the minus sign. We'll get 1.150 times, and then we need to grab our square root. We can do this couple different ways. Let's maybe highlight them both here, and then see if we can. There we go. Just highlighted them and hit divide by. And then I'm going to get outside of the square root there and press enter. So we get 0.317. Looks like we need to get, let's see what decimal point there. Two decimal places. So we need 0.32. That's our left side here. Notice that we're doing the 75% confidence interval. So that's why I grabbed that 1.150 as the critical value. We'll change that if we do a different level. I'm also gonna just, instead of redoing this whole thing, I'm just gonna go back, do the undo, and then shift right over here, do a plus sign instead, and that'll give us 0.42. So that's gonna be our right side. Get our 0 in there. And then the actual mean here, it says enter the population proportion. That's the thing we're technically trying to catch. And we typically don't know what that is, but because this is like a simulated problem, they're trying to show us how that all works out. Okay, let me see if, there we go, there's our 95%. So our 95% is going to be the exact same formula, except we're going to have a different critical value there. We're going to have a 1.96. Basically, the way it works, and this comes in the concept questions too, the bigger your percent, the bigger the critical value, or vice versa, the bigger your critical value, you can see that this number over here will get larger and larger as the critical value gets larger, which means you have a greater percent chance of catching the population proportion. So that's why it's a higher confidence level as we increase that critical value. So on our calculator, I'm going to go ahead and undo again. Let's do the, I think I just did the plus here. So I'm going to do the plus first with my new critical value. This is my 95%. This is going to be my right side of the interval since I did the plus. It's going to be 0.46. Let's see, here we go. 0.46. And then I'll go back and grab my minus, and which is going to give you 0.28. Okay, and then the mean doesn't change. I will point out, if you look at these two intervals, the 95% is much wider and it contains the 75%, and that's always going to be the case. For a given sample, now it changes sample to sample, but for a given sample, the higher the percent confidence intervals will always contain the lower percent confidence intervals. All right, so let's spin down here. We'll generate some samples, then let's answer some concept questions. So do notice that what's going on here, this red line on the left is the true population proportion. And anytime it's inside, you can kind of think of them as goalposts, football goalposts. Anytime that red line is inside, our confidence interval caught population proportion. In other words, it was inside the given range that we predicted it would be. But sometimes it doesn't, like right there. And over here, we see one even in the 95%. Occasionally, it's going to miss. So confidence intervals are approximate here. Here we go. It's possible that more or fewer than 95%. So it's going to be about 95% for a 95% confidence interval, but not exactly. So this exactly is wrong, and this at most is wrong. And that's going to be true for this question on every time on the proportion and on the mean. Confidence intervals are always approximately that percent. All right, these are a little trickier. You have to read them very carefully because they do change little wording here and there. So it says to guarantee a confidence level will contain the population proportion, you have to have the confidence level match the proportion. That's just hogwash. I mean, that's just nonsense. That means nothing. So this one's not true. There's no reason those two would match up. Completely separate things. If there were a sample of size n equals 160, the 95% confidence interval would be narrower. Um, let's check it out. So I guess ours was 110, 110. So what happens is if we increase the sample size, we get a more precise confidence interval. So our 90 by increasing the sample size, our 95% confidence interval is going to get a little smaller. And you can look at mathematically why that's true. The bottom of the fraction is going to get bigger. So this whole thing's going to get smaller, which means the distance you're going to the left and right is smaller. But anyway, this is not true because if we increase the sample size, sorry, this is true. 95% confidence would be narrower. I just read another problem where it said would be wider than. So it would be narrower, the higher sample size. Um, yep, we talked about this, how the greater confidence level, the wider the uh, range is, the higher the critical value is, all those go together. And this is true. We cannot say that there's a 95%. So the way probability works, since this has already been done, there's either a 100% probability because it is between those numbers, or it's a 0% probability because it's not. So we can't say that there's a 95%. We could say that if we're going to create one, then 95% of the time around that we'd catch it. But we can't say that once it's already happened, it has this probability. All right, we'll go ahead and check those just to make sure. And looks like we were correct.